Hi, I'm here to talk a little bit about at least one topic that I have a little bit of training on, and one topic that is fairly far outside of my formal training. I'm here to talk about stress and learning, and pretty much across the board these days, anytime we hear the word stress, we associate a negative connotation to it, right? No one says, I'm feeling stressed, and the response is, oh, great, right? Whenever we hear someone say, I feel stressed, we understand that that's not a good thing. I'm going to take my time today to try to convince you that stress isn't always a bad thing, specifically when it comes to learning. And in certain circumstances, stress can be a facilitator of learning. Stress can promote learning as opposed to hinder it. Now, of course, there are certain circumstances where the opposite case is true. And that's why my title is two ways that stress can affect learning. So, a little bit about stress. Just hearing the word, seeing it in giant letters on the screen, some of you in the audience have probably already had a visceral reaction to that word. We associate negative feelings. We have physiological reactions associated with stress. But again, there are very good things about stress. There are parts of stress and components of stress and certain types of stress that we need in our lives. There are two forms of stress that I want to talk about today. In the broadest sense, stress can be broken down into acute and chronic, right? This little girl running from a lion is experiencing an acute stressor. She is running probably faster than she ever has in her life. Her respiratory rate is higher than it probably ever has been. Her heart is beating faster than it ever has. Her eyes, her pupils are probably dilated more than they've ever been. And there's other things going on inside her that are less visible from an outside perspective. Parts of her brain are ramping up into this hyperactive mode, specifically a part of the brain that we call the hippocampus. This is the learning center of the brain. Another part of her brain that is in overdrive is the prefrontal cortex. This part of the brain deals in executive functions. It tells us, yes, I do want to eat that little Snickers on the table, or no, I don't want to get that cup of coffee at the break. Little decisions and big decisions. Both of these areas, the prefrontal cortex and the hippocampus, are in hyperdrive for this little girl at this moment. And all of those reactions, the increased increased heart rate, the increased respiratory rate, the increased activity in certain parts of the brain, all of these reactions are the product of a single hormone. And that hormone is epinephrine. And epinephrine is the first part of our stress response. So when we encounter a stressor, we get a huge surge very quickly in epinephrine. And epinephrine is really good at preparing our bodies to deal with these types of immediate stressors. It allows us to engage in what we call the fight or flight response. I'm sure you guys have all heard of that. Epinephrine is not very good when it's sustained over a long period of time. Imagine if your heart was beating as hard as it does when you have an adrenaline rush, if it was beating that hard all the time. That might do some damage to your heart, right? that might put you at risk for, say, something like cardiovascular disease. So what shuts down the epinephrine surge? Well, there's a secondary hormone, cortisol. This is probably the most well-recognized stress response hormone in the body. And it functions primarily to return all of those systems that epinephrine either ramped up or shut down, return all those systems back to what we call homeostasis, back to baseline, back to the pre-stress conditions. And so we have cortisol that regulates epinephrine, but what regulates cortisol? Well, cortisol actually regulates itself. It's a really finely tuned physiological system that the product, the hormone, cortisol, actually acts on the tissues that start its production and shuts those down. So cortisol regulates epinephrine. It also regulates itself when everything is working well. And when the stressor is relieved or averted, this is the type of pattern we see, with a spike in epinephrine and following a subsequent spike in cortisol. Now, you don't have to be chased by a lion to experience this type of physiological reaction, right? In fact, all of you experience, to a lesser degree, this exact reaction every time you wake up in the morning. The physical act of getting up and getting out of bed produces this type of reaction, this type of endocrine response. The problem that occurs is if the stress isn't resolved, okay? So if stress, instead of being a lion that chases you and you either escape or don't, if that's your source of stress, it's over within a few minutes in all likelihood, right? In our society, more and more of our stress comes in the form of chronic stress. Less and less of it comes from these acute stressors. Chronic stressors are the types of things that don't go away within a few minutes. They persist for days, weeks, months, even years. Okay? And the endocrine response to this looks more like this, with epinephrine and cortisol being maintained at elevated levels. Okay? This is a problem, right? The reason that this is a problem is that when these two hormones remain elevated for extended periods of time, the tissues that they're supposed to act on essentially stop responding. So under conditions of chronic stress, when we do encounter an acute stressor, we're less capable of responding appropriately. Okay, so what does all of this have to do with learning? In February of last year, the American Psychological Association published their report of a study called Stress in America. And in this study, they surveyed over 1,000 teenagers all over the country and asked them lots of different questions about their life, about their academics, athletics, life at home, a whole bunch of other aspects of their lives. And I want to highlight a few of the results of that study that I think pertain particularly to this talk. One of the results was that about 35% of the teenage girls and about 25% of the teenage boys reported feeling depressed at some point in the previous year due to the level of stress in their lives. Okay? That's, to me, those are numbers that are way too high. A second point, nearly half of the teens surveyed reported having stress levels that they felt were unmanageable. And the third point was that over 10% of the teens surveyed reported having decreased academic performance that they attributed to having too much stress in their lives. Okay? So all three of these things are saying stress is bad, stress is bad, stress is bad, right? Okay, I'm going to talk for the next 2 minutes and try to convince you that stress isn't always bad. So here we have one of the processes that is critical to learning, and this is known as long-term potentiation. What's being shown here on top are, in yellow, are neurons that are synapsing onto purple neurons below, which are not showing up great. But over time, when one neuron fires synchronously with another neuron, it strengthens the connection between those neurons. This concept, of long-term potentiation, should be familiar to all of you. We've all done it. Rehearsal is the behavior that we use to make long-term potentiation happen. Anyone that's memorized your multiplication tables has engaged in long-term potentiation. What's important with regard to stress is that epinephrine facilitates this process. So when epinephrine levels are elevated, long-term potentiation happens faster, and learning can occur more rapidly. This concept was tested explicitly by a study in humans where people were shown a series of images, and they were injected with either saline, essentially a sugar pill, or 2 doses of epinephrine, low and high. That's what's shown in the gray and black bars, respectively. And then a week later, they were brought back in and asked to report how many images they could remember, right? Those participants that were injected with the high dose of epinephrine reported the highest recall. They were able to remember these images better than those that were injected with saline, with the control. And there are a slew of other publications that I could have drawn on, but I thought this one demonstrated this most explicitly. Getting back to the other side of stress, when stress persists for a long period of time, so instead of just getting an injection of a set amount of epinephrine, instead, if we just have elevated levels of epinephrine or elevated levels of cortisol for days, weeks, months, that's when we can run into real problems. So this is showing 2 brains, one from a depressed individual and one from a healthy control. And we see dramatically different activity levels in these 2 brains. Okay? Depression is one potential way that chronic stress can manifest itself. There are lots of other ways that chronic stress can manifest itself. But this one is one that's been most highly studied. So I want to reiterate one last time that stress can be a good thing, can potentially be a bad thing if it results in dysregulation of our stress response systems. And I'd like you all to engage in one short exercise that hopefully will help you remember this talk. I'd like you all to stand up. Congratulations, you've increased your epinephrine levels, and you should remember this talk a little bit better. Thank you.